in the case of GA. But GP does have it, and that's probably why someone said, let's let GA have it too. So let's make that note, and let's do one example, and we're done with cut and splice, and then we'll be done with all the crossovers. Then we do our one example of mutation, and we're done with mutation for today. Tomorrow, we're going to explore respectful, so we're going to do a whole new slew of crossovers and mutations, but we'll talk about what respectful is tomorrow. Okay, let's do this now. Okay, what do we say? It's called the cut and splice. Cut and splice crossover, probably, because I didn't check up who created this, but I believe this is probably inspired by what happens in genetic programming. Now, this is, I really should spend more time on this, but it'll only make more sense when you or listen to the Amoeba Sisters. This is the most unbelievable, awe-inspiring aspect, one of them anyway, and every aspect of genetics and biology is, but this little detail, in my opinion, you'll tell me otherwise, but in my opinion, is probably the most awe-inspiring detail in my mind in genetics, which is the fact is that cut and splice crossover pretty much absolutely never happens in real genetics. The fact that it doesn't, is mind-boggling, and for today I'll just cross-reference to you notions of introns and exons in genetics. And just point, and for homework, although I don't know if we'll do it tomorrow, because we have enough to do for tomorrow, but hopefully at some point I will deal with that. I'm not going to spend too much time, but hopefully you read up on it, and they do talk about it, at least briefly. But anyway, introns, exons, and exons. So in fact, cut and splice basically never happens in real genetics. It's a mind-boggling question. Why not? I mean, the answer we know. The technical answer is because of introns and exons. That just gives it a name. That tells you what you're observing. It doesn't explain how come it didn't ever come this way. Anyway, it's unbelievable. But here's the idea: cut and splice introduces the notion that the genome length can change during the process. Okay. In the actual mitosis situation, that never happens. Now, could a very extreme rare mutation exist? Maybe. But we'll talk about mutations in a second. We only have a few more minutes. The fact that this never actually happens is mind-boggling. I'll leave it up to you to figure out all the details of that. But that is, to me, is awe-inspiring and mind-boggling. Anyway, here it is. Let's do the example. Enough said. You'll decide on your own. All right, so let's take a before. So since the way this happens is that each piece, each strand has its own selected crossover point. So here we're going to assume B3 for bit string 1, but B5 for bit string 2. They are independent. What you call it? Apologize. Crossover points. Yeah. Okay. Here we go. So let's start before the same before as above, but now notice that the crossover points are not aligned. Right? B3 after B3 for bit string 1, after B5 for bit string 2. All right. So now there are two versions based on Shuhua's comment, right? So you're going to get one of two possible versions. Either you're going to get this. Let me get it for you. Oops, no, that was not it. Hold on a second. I copied wrong. I'm sorry. Better. Okay, now let's do it. Either you're going to get this, which is that the second piece of bit string 2 becomes the second piece of bit string 1, and the second piece of bit string 1 becomes the second piece of bit string 2, That's if we make the default as not allowing. Otherwise, no, I think it'll be the same thing. Give me 1 second. Let me just think. 1 second, please. Yeah, in the end, it's going to be the same. In the end, it'll be semantics. In the end, it'll be who's child 1 and who's child 2, but the result will be the same. So let me not make that comment. Okay, so here's the bottom line. So we're going to use the same version as we did before. We don't have to make new version. The version we assumed is that the crossover happens after, in which case the first piece is a default. Okay, so here it is. So 101 is from bit string 1, and then you take 110 from bit string 2. On the second child, you take the 00100 from bit string 2, parent 2, and then you copy 10101 from bit string 1. What's the result? You started with 8 bits each, and now you have 6 bits versus 10 bits. That is cut and splice. So again, whereas in GA that never happens, in real genetics it never. GA, if it models true genetics, it should never happen. But the fact is, in genetic programming, it pretty much always happens, and we'll talk about more of that next week. But anyway, we still have a few more minutes, and that's all we need for mutation. Mutation is very straightforward, and there's only 1 or 2 comments I make, and then we're done. But any last question? Not last, I don't want to push you out, but is there any other question about this example? It's very straightforward, I think. All right, so now, I'm sorry, yep, okay, let's see. 1 second, sorry. Length of bits are allowed to change. No, that's the point, Mohammed. Correct. We wrote this above somewhere. The assumption is that the number of bits is fixed prior to GA. Cut and splice allowed it, but it's on its own. And they allowed it because in genetic programming that is allowed. We'll see why. It's the nature of genetic programming allows it. But in the nature of GA, it does not. But some people want also GA to have such a notion, so they make this version. The fact is, no, you don't want to do this. It's very special situations if you need it. But the assumption is that the length are fixed. All right. So, I'm sorry. Right, exactly. Well, okay, so Muhammad, this begs your question above, which is the rule of mutation. You see, despite Hollywood, and this is what I was going to say a second ago, but you're bringing it up now, which is fine, so I'll mention it now. Despite Hollywood's attempt to convince people that mutation creates amazing powers, Spider-Man, Ninja Turtles, what are they called? Teenage Ninja Turtles? I'm probably missing a word, I think, right? All of these are mutations, right? And it creates genius and strength and agility and all these great things. That's Hollywood. The fact is, and sadly so, that in real life, mutation destroys the species. Unfortunately, mutations are sources of all cancers, and it's very rare that a mutation actually helps the organism. So it's sad. So when you said it might be a new species, it may be a new species in the abstract genetic or abstract GA or abstract computer simulation world, but in reality, unfortunately, that doesn't really happen, unfortunately. All right, Waleed asked, so this kind of non-fixed length is the only thing... No, Waleed, that's the crazy part, and that's what Muhammad asked above. These wild versions are not mutations. These are crossovers according to GA. So you're asking a good point, Waleed. You know, it becomes the semantics, but we have to stick to the literature. In the literature, this is a crossover, right? It clearly is a one-point crossover. So despite the fact that this is wild and what you observe as mutation, the literature will never call it that. Everything till now is crossovers, despite how wild it is. Yeah, right. So that's an important point. In fact, let's emphasize that. Despite how unconventional and or wild, unconventional the result may be from any of the above, the literature clearly calls all of the above crossover. that's very important. We now give an example of mutation, which in the literature, is based or inspired by uniform crossover. Okay, that's the favored technique. And there's only one in the classic literature. Tomorrow will come 5 simple versions. Fortunately, it's mutation tomorrow will be easy, simple, but there are like 5 versions in the respectable realm. But in the classic realm, this is in the classic realm. Respectful will be dealt with tomorrow. Okay. All right, so one example, fortunately, you only need a minute or two. It's quite easy. But let's grab the data from the, and you'll see in a second. So right here. Let's take this uniform part. Copy it. But we'll change it. But this basically is the rubric, because we say similar to, and that's what it's inspired by. Okay. Mutation in the literature literature, I don't know. Okay, is implemented similarly to uniform crossover in a way similar to, not identical, but in a way similar to uniform crossover, and is the favored approach, favored version by researchers. Good. All right. The probability rate. I'll edit this more in later after we finish. When I'm almost done. Let me cut out. Here. The probability rate in this context is not called the cross. It's not. Oh, that's a mistake. It is called above. Oh. I didn't realize. Let me just, because I caught it now. Hold on a second. I didn't realize that. The probability in this context is rather called, not called, it is called, is rather called the crossover rate. Where's this? Over here. Yeah, but let me do it above too. Give me 1 second, I apologize. Where did I put it? Shuffle and uniform. Sorry, I didn't realize. I wouldn't have caught it otherwise. So I just want to get it done with. Is rather called, not called, it is called. It's rather called the crossover rate. But and over here, it's rather called the mutation rate. All right, here we go. Now, it won't be so high. Oh, you know something? Yes. All right, we're going to do the same thing. Just to speed this up, because we're end of class, I want to finish this. We're going to assume that the mutation rate, and you'll see the difference in a second, the mutation rate is equal to 0.3. As there are 2 ways to implement this, that's true. The same thing is the same, that the mutation occurs. Mutation, actually I should do a global change. I know, too late. Let me just do it already. I'm almost done. By research. Please note again, these are now if the not uniform crossover is to perform mutation again, we'll need to do a new number of speech bit. Good, excellent. Okay, now one major difference here, of course, is that there's only one. Okay, maybe that isn't clear. Mutation involves only one strand of DNA produced after crossover. In the real world, in real genetics, it rarely occurs at all. But we allow such a process to more readily exist, not very readily, but more readily exist in GA. In order to encourage the variation of the genetic material, right? The variety, the variation of the genetic material in the what's called we've been calling the next generation. For all you Star Trek fans. And well, whatever, you get the joke. All right, now, okay, so now let's keep these numbers. So, question is mutation, question mark. So we're going to do less than or equal, for example. So no, 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 yes, no, 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 yes, yes. Okay? And let me just do this. Let's just format it correctly. Okay, last one, and then we're done. So the result is only one child, the final child. All right, so 1 is no, 0 is no, 1 is no, 1 is yes, so it becomes 0, but not because you're copying. It becomes yes because 1 is mutated to 0. The mutation simply flips the bit. Okay, bold. The mutation simply flips the bit. The complement of the bit. Oops, I thought I bolded it. Okay, next generation, mutation. Let me split a period here. Fine. Okay, so again, mutation, no, no, yes, yes. So the 1 became a 0, no, no. The 0 became a 1, and the 1 became a 0. That will be the result. Okay, last question by Mohammed. Well, over the example. That's it. We're done. That's mutation. We're done for today. Let's answer Mohammed. Professor, to clarify, crossovers happen from parent to child within the individual. Correct. So the answer is yes, but don't be so as surprised, and I'll explain why. What you're feeling as a confusion is not a confusion, meaning you didn't misunderstand any of the material, so feel better about it. This comes back to an unfortunate, it's not that my comment is unfortunate, but the comment I made yesterday is it's unfortunate in the literature that the GA people sort of were very lax and do not, for the most part, differentiate between the various major levels in real genetics. You have a gene, you have a cell, you have a chromosome, you have a strand of DNA, you have an organism, you have a genome, you have an organism, you have a population generation, right? You have many, many levels. Unfortunately, most of them collapse and refer to the same thing. So in the GA parlance, in their way of talking, the genome is the individual, is the gene, is the chromosome, is the organism, is the. That's where these things get messed up. So what is the child? The child should have been not the strand, the child should have been the organism, but they reuse all the same terminology. So technically what you're saying is true, it's just that it's because of the confusion that the literature created that you get these funny ways of describing it now do. But it's not because you don't understand the material. You're understanding. It's just that they were sloppy. Okay, Mohammed, does that help you? And Shua will 1 second. Okay, good. So Shua asks, can I go back to line 61? What's the meaning of 4 and 2? I'm absolutely happy to help you. Let me go back up to line 61. We may have added a line, so you'll tell me. Line 61, you said, right? All right, let's go up to line 61. Oh, yes, absolutely. AGT, what's it? ACGT, right? Are the 4 amino acids. And if you wanted to numerically represent the DNA strand, you could encode it by an integer. With base 4 arithmetic. To be more specifically, let's say A equals digit 0, C equals digit 1, what's it? G. You'll look it up. letters of the amino acids. I forget the actual biological names. When you listen to the what you call it, the Amoeba sisters, they'll tell you they're well known. I just happen to forget what they're actually called. Digit 2, and then T is equal to digit 3. So you can encode a whole strand based on base 4 arithmetic. Okay, Shua, does that help your understanding? Yeah, correct, exactly. Thank you. All right. Yeah, thank you for saying this. Shua, so does that answer you for that point? Thank you so much. I'm going to copy it right here. I just copied you what you texted. So I'm going to trust you, and hopefully those are them. I believe you're correct. And 2 is binary because but in a computer. But a computer, well, got to be careful here. This is interesting, and I won't discuss it this semester, but I alluded to about my theory quest next semester, so we will there. But a computer, we got to be a little careful here, really Western European influence. Has only bits equal to binary digits 0, 1 at its core memory. As this memory can be encoded by a base 2 integer arithmetic. This memory can be encoded what we call bits, but we know that Boolean, as this can be encoded by a base 2 arithmetic. And you're correct, which is 0, 1. Does that help you? Good. Okay, excellent. All right. One little, it's a sad anecdote. I find this very sad, but supposedly, I have to check it up, but I've been told it's pretty accurate. Anyway, George Boole, who is Boolean and did all that math, wrote a memoir of his autobiography or something. Anyway, it's written there that at the end of his life, he spent his entire life in base 2 arithmetic, and he sadly says, it's a shame to think that his entire life's work is for nothing, because he couldn't think of a single application of all his Boolean arithmetic, and that bothered him. And he in a tragic way, he passed away without seeing the fruit of his labor. But we know that that's the basis of all computers, at least, again, Western European influence. In other countries, Eastern European influence, they actually use base 3 arithmetic because it's closer to the entropy number E, and I don't want to get into it now, but in next semester, if you ever take my advanced theory course, I'll have a little discussion about that. Okay, that is the end of class, and we did a great job, so congrats, and I will email you this. I don't have to email you my other version, because basically I copied and pasted the important parts here, so this is good enough. All right, if you have any questions, if you didn't have a chance, kindly text that you were present, and otherwise I'll see you all tomorrow. What is this? Version 7. I don't know what I did there, but anyway.